So we finished with main types of compressors, and now we're going to another components of air supplying system. The first one is the cyclone condensate separator. Use centrifugal motion to force liquid water out of compressed air. The spinning causes to the condensate join together on the centrifugal separator's wall. When the condensate gains enough mass, it falls to the bottom of the separator bowl, where it spools in the sump unit and is flushed out of the system by automatic float drain valve. They are installed following after cooler to remove the condensate moisture. The separator can also remove the oil from the air. A mixture of compressed air and oil leaves the air end and is passed to the separator, whereas most of the oil is removed from a compressed air using directional and velocity changes. Then condensate filters are used to remove the remaining oil, resulting in very low oil carry over, usually between 2 to 5 ppm. This means that air that lost this separator will be less oil than a regular one. Condensate drain. Condensate drain is needed at all separators, filters, dryers, and receivers in order to remove the liquid condensate from the compressed air system. File drains can allow slag of moisture to flow downstream that can overload the air dryer and full end user equipment. Main type of condensate drains is zero air loss, electricity operated solenoid valves, float operated mechanical drains, and finally can be manual drains. Pressure vessel mounted after compressor, its size depends on flow rate in the system. Pressure vessels play a very important role in compressed air system. This damping pulsation caused by piston compressors, proving a location for free water and lubricant to settle from the compressed air system, supplying peak demands from stored air without needing to run an extra compressor, reducing load and start-stop cycle frequency to help screw compressors run more efficiently and reduce motor start, slowing system pressure change to allow better compressor control and more stable system pressures. Compressed air dryer. Compressed air leaving the compressor and moisture separator is normally warmer than the ambient air, is fully separated with the moisture. As the air cools, the moisture will condensate in the compressor air line and can result in undesired pipe corrosion and contamination at point of end use. For this reason, some kind of air dryer is normally required. Some end-use application requires very dry air, and for this method, the second stage air dryer are used. Common type of air dryer include refrigerant, desiccant, and membrane dryers. Refrigerant air dryers are considered economical to purchase and operate. They remove water by cooling the compressed air temperature and causing condensation. An internal moisture separator collects the liquid water and send it to the dryer. Refrigerated dryers typically generate air with pressure dew point between 0 to 5 centigrade. They tend to be used in general plant operation. They may not be suitable for more critical processes that demand extremely dry air. They aren't designed for circuits that see sub-freezing temperature. They fall into two categories, cycling and not cycling. As the name implies, one type runs intermittently and the other runs continuously. Users should consider cycling dryer, which only power up to meet demand and thus reduce electricity consumption and energy cost. Desiccant air dryer work on a different principle. They absorb moisture from the air stream onto desiccant material in a reversible process. They produce low dew point, so they are good choice in sub-freezing conditions when their processing require extremely dry air. There are two types of desiccant air dryers, heatless and heated. Heatless desiccant dryer house a desiccant material in two tanks called the drying tower and the regenerating tower. Moisture-laden compressed air flows into the drying tower, where it's passed over and binds to the porous desiccant. Extremely dry air with pressure dew point of -20, -40 centigrade exists at dryer. Heated desiccant dryer, as the name implied, have a heater in the circuit. Much like the heatless version, desiccant in one tower remove moisture from the following air. Resulting pressure dew point against can range from -40 -20 centigrades. When weighting the virtues of heatless versus heated desiccant air dryer, keep in mind economics. The cost of generating compressed air can be sizable, and heatless dryer use more about 50% of compressed air than heated one for generation. On the other hand, heaters can require a lot of electricity. Thus, users should review the specifics of the application to decide what types cost less to operate. An additional type of desiccant dryer is the heat of compression dryer. These are special version of desiccant dryer for reuse heat generated by oil-free compressors and are highly energy efficient. In heat of compression dryer, hot, about 150 centigrade high pressure air from a compressor first travels to the regeneration tower and frees moisture from the desiccant, flows in exit and pass through an aftercooler, reducing air temperature to around 40 centigrades, and then removing some water. Cooling air then runs through the dryer tower and exit with a dew point of approximately -40 centigrades. Heat of compressed dryers coupled with oil-free compressors generate high-quality compressed air free of water and oil and are suitable for food, beverage, and pharmaceutical manufacturing application. Heat of compressor dryers cost more upfront compared to refrigerated and conventional desiccant dryers. However, because they are powered by vast heat from the compressor, operational costs of these dryers are minimal. Let's speak about advantages and disadvantages of generic desiccant type dryer. Advantages include very low dew points can be achieved without potential freeze up, moderate cost of operation for dew point achieved, heatless type can be designed to operate pneumatically for remote, mobile, or hazard application. Disadvantages of this type of dryer are relatively high initial capital cost, periodical replacements of desiccant bed, typically every 3-5 years. Oil aerosol can coat desiccant material, rendering it useless if adequate pre-filtering is not maintained, and pure air usually is required. Membrane air dryer is another type of air dryers that is designed from conventional point of view drying without need for electrical power. Membrane dryers utilize hollow fiber membranes to remove water vapor from compressed air. Membrane dryers operate on the principle of migration. The compressed air to be dried is passed over a membrane that has a high affinity for water vapor. The water vapor will on the membrane and migrate through the opposites of a low pressure side. Membrane air dryers are compact, lightweight, require no power, and have no moving parts, so they cost little to operate and do not require routine maintenance. The disadvantages of this dryer are they require about 15-20% of pure air. Membrane dryers reduce the oxygen content of the compressed air and cannot be used in a breathing air application. And flow rate of a single dryer is up to 10 normal meter per hour. Some general recommendation for dryer choice. Don't always specify a dryer. Operation every patch of compressed air system at the lowest possible dew point is rarely necessary. It's expensive and almost always wasteful. On the other hand, don't scheme on drying and specify dew points that are too high. Damage from water in system is equally expensive. Users should only supply the degree of dryness needed for each application, especially when it varies by process or machine. And like any system, consider upfront and operation cost, flow rate, and performance capability when specify a dryer.
Slide 26. Compressed air filters are used for high-efficient removing of solid particles, water, oils, aerosols, hydrocarbonates, odor and vapors from compressed air system. To meet the required air quality, appropriate filter element must be installed into filter housing. Common types of filter are particulate, removes water, oil and solid down to 3 microns, coalescing, removes solid and liquid particles down to 0.01 micron, absorption, absorb vapors and odors.
For this matter, the type of absorption filter can be used that named activated carbon tower. That eliminate hydrocarbon vapors and odors from the compressed air. Towers are filled with activated carbon adsorbent that absorb contaminants onto the surface and internal pores. Activated carbon towers are used at application where the content of vapor needs to be reduced to a minimum. Activated carbon towers can be incorporated in existing compressed air system, significantly minimizing the risk of contamination.